This is actually the first all-student built standalone spacecraft that's going to go into orbit, and it's going to stay there to complete its mission, versus the gas canister, which is something that comes back. The goal of RAX is to study space weather anomalies. The particular anomaly we're studying is called magnetic field-aligned plasma irregularity. What happens is these irregularities can prevent communications from our ground command stations to our spacecraft up in orbit. So what we're going to do is study when these anomalies form and under what conditions they form. And we're going to collect data over a period of years so that we can create forecast models to predict when they're going to form. And just like you get your weather in the morning, scientists and spacecraft operators can get space weather forecasts in the morning as well.
Students are project leads on power, communication. They are fabricating by hand a lot of the parts. We have advisors, we have academic advisors, professors, we have professional staff, professional engineering that come in and give advice. But it's really the students that are carrying the brunt of the work.
My role has been to be the GPS lead, so we're concerned with the timing and the position.
I'm the main flight programmer for RAX, which means I program essentially the operations and what goes on during experiments and flight operations in orbit.
RAX really motivates everything that I do in my research. So my research is kind of theoretical, kind of analytic, but to be able to say there's the spacecraft will be able to get more data down or operate better because of what I'm working on is really a nice motivating factor.
I'm sitting in meetings with universities, with Department of Defense, with Air Force, big aerospace companies that are building this spacecraft. I'm sitting in the same room with them and briefing the colonel in charge of our launch, saying, yes, we're going to be on time, sir, yes, this is what our status is.
It's awesome to think we will have a spacecraft up there. We'll be able to talk to it. We'll be able to apply some of the research we're doing on it.
What's it going to be like on launch day?
I'll probably be a nervous wreck.
It'll be incredibly nerve-wracking.
It's going to be a heart-pounding experience. There's no doubt about that. We are all either going to be standing in Alaska watching her go, or we're going to be all standing very close to our computers waiting for that first signal to come down from RAX.
And I'll also be incredibly excited when it makes its first pass over Michigan or wherever we are, and hopefully we're able to communicate with it. It'll be exhilarating, I'm sure.